Okay, welcome back to Hudson's Hacks. This is going to be the third in a series of tutorials we've been looking at. The first one had us training a machine learning classification model on a stranded patient dataset available at the NHS All Datasets package to download. We showed you how to do that in the first step. We then serialized that model in the first step, and this could then be retrained weekly, and I'll show you as part of this tutorial how to set up that task schedule process as well. Secondly, we then took that model and we then said let's put it into a Docker container, let's push it in. So we created a Docker file and we had all the files that we needed to create that Docker container. Refer to the second video in this tutorial. The third video, which is this one, is in response to a lot of questions I've been getting from people saying, okay, we've got this great Docker container and I like the Swagger UI that we created in JSON. It does make it interoperable. But how do I actually interface with R? So say I've trained my model as the first part of the phase. I then deployed it into Docker as the orchestration step, so it's available for everyone. I want to set that's the start of my pipeline. The end of my pipeline will be just consuming this with unseen data. So I say unseen data, this will be live data running from a database, streaming. I want to pass it to that model and get my predictions back. And that's where this tutorial comes in. So it's going to be consuming our API from Docker with R. So I'm going to take you through this today. And first of all, I'm just going to refresh you on what our Swagger UI looks like. Okay, so we've got this Swagger UI that we created in the last tutorial. We've got a get, so we created a get request, so getting data from an API. And this just pulls back simple things like the connection status, it gives a message, the time that it was connected up to, and the username. And we've got this post, so we've got this post request, and it's called predict, so that's the handle at the website. At the end you'll have docs and then you'll have predict at the end. If for this one, to get the connection status, you'd have connection status. So if I just copy this, you'll see what happens. So you can see that that's actually a JSON string now. We can get that as a JSON string. For a post request, it's a little bit different. We'd have to pass each one of them so into predict, and it gets a bit messy here. We'd have to pass in the post, so it'd be age equals to 52, and then you'd have an, and it gets messy, so we're going to use R to do that for us. And that's what we did essentially in the last tutorial, so refer to that in, sorry, the first tutorial. So refer to that if you need to just catch up. This structure was dictated by a YAML file that we created. So if you look at the schema, you've got age, so the age of the patient, whether they were referred from a care home, something called medically safe in hospital terms, so can they be discharged medically safe, whether they're a member of the health care for elderly people specialty, if they need mental health support, how many previous care inpatient stays have they had in the last 12 months, have they got any activity limitations, so mobility problems. Again, that's another flag. Do they have a history of falls, which is something else that's closely monitored in hospital settings in England and Scotland and Wales and Northern Ireland. Should I just say the UK? So we've got this Swagger endpoint. It's all cool, but I'm going to want to consume this part of it, so the post request. We're not going to focus on the get request because it just returns status updates. The post requests where we're going to really work with. So if you don't know what a post request looks like, it's essentially something that you learn about when you're doing web design. So a post request is HTTP, and it sends a request through to a website. So in computing and post, the request methods supported by HTTP. It requests methods that the web server accepts, the data enclosed in the body of the request message, most likely for storing it. It's often used when uploading a file or submitting or completing a web form. So that's essentially what we're doing. You know, when you fill in a web form on the internet, that's a post request. Or if you want some shopping, or you register for a conference or whatever, they'll all be examples of post requests. Okay. So we've got this Swagger endpoint, and now we're going to use R to interface with that endpoint. So I need a couple of packages here. So I'm going to need my HTTR for connecting up to HTTP. I need JSON Lite for working with JSON. I'm going to need RJSON as well because there's a couple of handy functions in there. I'm going to need dplyr and data table just for fast loading. So we're going to run these first of all. Just let me bring the console window up. Okay. So data table says that it's using parallel, so it's using threading. So we're going to read in our production data. So assume you've got a live environment. This could be accessed via SQL. It's going to read in, it's going to do a SQL query. It's going to get all the patients that have not been trained in the model. So you could have some flag saying was in the model training step, was not. And what we're going to do is we're going to JSONify this. So we're going to take in our input data frame and I've created a little helper function here. So the prod data is going to do the data table method. It's going to read it in as a data frame. And then JSON new is going to use the toJSON method from the production data. So it's going to create a JSON string. And then at the end, I create a list because I'm going to want 2 returns because R's default doesn't have multiple returns. You have to create lists to create multiple returns. So it's going to give me a JSON string and a data frame. So let's just run this function. You'll see it appear in the environment. If you clicked on that, it gives you the function breakdown and parameters. We've only got one parameter. It's just going to be a data frame. So inside of, so I'm going to call this function that we just created. Inside the data folder, if you can see that on the right, I've got this production CSV dataset. So essentially from your server, this would be a live dataset that keeps getting updated, and then you want to pass it through to your model and get your predictions. So I'm going to run that. So it's going to give me a list of returns because we created a list, 2 outputs, didn't we? So it's going to give us JSON and it's going to give us a data frame. So to expose those elements, if you can see what the titles or what we called them, df is the list element there, and JSON's the list element there. So for the prod data, I'm going to get my prod data. You can see that I've got quite a few observations, so new observations that have not been trained on the model. And I want to make these predictions. So I want to find out if the model's predicted whether they're going to be a stranded patient or not. Because we don't have the labels for these yet until at the time they become stranded within 7 days. So say this is their first day that they're in hospital, the first inpatient stay, and we want to predict whether they're going to be stranded. And the kind of benefit of this would be to say to your bed coordinators or people that deal with capacity that actually on day 1 we are predicting that they're going to be here longer than 7 days. So actually you need to make beds available for the next 6 to 7 to 8 days. And it'll help with capacity and planning requirements. And this is essentially the reason. This was a live model that I created when I worked in the hospital setting as a machine learning tool. And they found it really helpful, especially going into community. You'd have essentially social care provision after the end of this. Obviously the model that I had lots more variables than this. This is a very much a simplified version of that. Again, if you want to find out how to about this data set, if you go to the NHSR community page or NHSR datasets in CRAN, you'll find that I've co-authored this with a number of my NHSR community buddies. So myself, Tom, Chris, Zoe. And if you want to look at the types of data and how to work with them, if you look at the vignettes, you can see that we've got a length of stay model, so that's a regression problem. A&E attendances, another dplyr regression problem. We've got a mortality data set. We've got a stranded model, and this is what we're using. So the stranded model shows you what it's all about, what the data fields are, how you could feature engineer it to get more out of the data, how you evaluate it with confusion matrices, etc. So we've got this data, and these are the unseen predictions. So we want to make predictions on whether they're going to be stranded or not. And then you can get the JSON as well. So I've got the JSON string. So that's how it would look if we were passing it as raw JSON. My typing's not good. So you got the raw string, and it's encased in JSON tags, as you can see here. So list item, you've got your JSON tag there. So it's passing multiple values. So you've got an age, and you've got all these multiple items as lists that you're going to pass through. So a JSON list, similar to Python, if you know that. The lists are always the square brackets. Okay, so this is the sexy part then. So this is just loading in the data from a data frame, making it a JSON string. I'm going to pass this JSON string through to our function, but I also want the original production data that's come through as a data frame, because we're going to bind onto that later on. Okay, so let me take you through these steps. So this function is a series of 6 steps that I coded out initially individually, but then I changed it into a function for ease, should I say. So we've got the post to API, and we're going to use our URL. So our URL is going to be this URL here. This is going to be the predict method, the post predict method. So I know that URL will be just this, I think. So that'll be that URL there. Our IP address and our predict, so our name of our endpoint. And we know it's got a predict, yeah? So we're going to connect up to that later. It's there. But in HTTR, it lets you do a lot of the standard HTTP requests, so post, get requests, etc. So we're going to use the URL that we're going to pass into there. The body is going to be this JSON string. So can you remember we created a string from that data frame? And it's going to pass in the age, and it's going to pass in all these multiple ages. And then it's going to say, oh, actually, list item 1 or 0 indexing, depending on what platform you use. List item 1 is 52, and then it will look to the next index on 52 for the next parameter, which will be like previous periods of care, etc. So it's going to put that body JSON through, and we're going to specify the content type. It's actually JSON, because we're going to pass in JSON string through to our API. Again, just let me refresh your memory. If you passed anything else, it wouldn't work. So it's got to be JSON. So then there's another HTTR function called stop for status, because it's going to send the post request through, and if you don't wait, you're going to get a connection result saying it's successfully connected, but you're not going to get any of the response body, which is essentially, if I ran this now, if I tried this out and just did it with the default parameters it gives you, execute it, you can see that I've executed that. I've got this request URL. That's my curl request string, which is essentially what HTTP is sending out in this part, is that curl request. And then this is my what's called response body. So it gives me those stranded and not stranded probabilities, and it will say if it's connected successfully or not. So I know that it's connected successfully because I've got code 200. So you've got this response body and you've got these predictions. And for this is very much a not stranded patient. So what we're going to do is we're going to do this for multiple patients, because we've got 450 observations, and we're going to get that response. So this is really important, this stop for status. Without that, it'll only give you the status. So then the next step, so we've made a post request, we've sent it through, we're waiting for the status, getting it back for each one of those 450 observations. The request body can get those content from the results. It's going to parse it, and it's going to parse it to JSON, and then we're going to send the results back to JSON. So request JSON, and we're going to convert it to a JSON to the from the request body here, because that's the result. So result back to JSON, and then we're going to use a special parameter here as data frame. I'm going to use the do call method. So we're going to rbind. We're going to bind the rows together, and because this will return a string if we didn't do this result, we're going to list apply it. So we're going to loop over every one of those in the request body, and we can convert it to a data frame. So essentially, it's going to be stranded, not stranded as a pair. This will just put them as a string across. That's why you need this method to convert them back to a data frame. So not stranded and stranded. Finally, we're going to store our lists as our results here. and that function then has got everything that we need to work with our API. So now we've got that, what we're going to do is we're going to actually connect up to it and get some predictions back. So we're going to run our URL. See our URLs now are in our global environment. We're going to access this post to API function that we just created. So I'm going to pass in that URL. I'm going to pass in that JSON string that we created as part of the first part of the process. So just to remind you, this massive string of multiple values with the key and each of the values here. So you've got the key needs mental health support, and each one of the values encapsulated in the list. So that'll be encapsulated for every page 450 times on that line, 450 times on that line, until we've got down to those 9 variables. So if we count these tags here, you'll have 1, that's the first variable, 2 as the second variable, 3 as the third variable, 4 as the fourth variable, 5 as the fifth variable, and so on until we get to 9. And the last one will be mobility problems. So if we wanted to check that in our data frame, we can see that we've got this frail mobility problems there. So look at everything in the data that we need. Okay. So we're going to do this call here, API call results. And you can see that I've got this list of 4. So it's going to give me back the HTTR request, so the original request, the status code, say it's successfully connected. Then it's going to give me these list of values. And this is why we needed to do this special rbind lapply function to create it back into a data frame. Then we've got this prod data that we're going to bind it onto. So now we've got our predictions. We're going to create this data frame. So this is your predictions based off that data frame. So let me just go up to the DF. So you could call that whatever data frame. So what you should have now is our original data that we fed through into the function, and then our predictions. So what's happened is it's gone to the API, it sent all those predictions through as a JSON string. It's then said, okay, like it did before, okay, I've got all your predictions for you. Let's wait until the response comes back. You've got this response body, and it will give you all those predictions as in terms of probabilities. So if we look at that DF now, and if I put it into my environment, I've got the probability of not being stranded over stranded for every one of those 450 patients. What we're going to then do, finally, is we want to bind that data back on. So we've got this prod data, and what we're going to do is we're going to bind through this DF, or we could call that predictions, whatever. I'm going to call it DF for now. You could call that predictions. And then we're just going to create a new column. I'm going to call it class, and then we're just using an if else function. So if else the class label stranded is greater than 0.5, then we're going to classify it as stranded, otherwise not. And you could kind of tweak this threshold if you wanted to really be strict on your model. So we only want to be 80% confident or 90% confident that they're stranded, and tweak that. We're just going to say if it's greater than 50%, then it's more likely to be stranded based on the representation and the patterns in the model. So this is then, if you saw that increase, gone up from 9 variables to 12. So at the end of this data set, you'll have what we think the predictions are. And the only way you'd then know what the class would be, if you wanted to track it for accuracy later on, is when this person becomes stranded or not, when they're discharged. So this is when they've been admitted into ED at the start of the process. You'd have to wait, say, 4 to 5 days to find out if they were stranded or not. And then you can feed that back in as a feedback loop into your training process to say, actually, your model's just not accurate enough. It's not predicting on the unseen data well enough. So try some other modeling techniques in terms of machine learning classification models. And again, if you want to find out around Carrot and how you can create different models and different options for that, I did a talk for the NHSR community on advanced modeling with Carrot. and I showed you how you can boost some of the weaker models using something called ensemble learning, so check that out. So that's accessing our endpoint. We've got those predictions back, and then you could store them into, you could send them to a database, you could write them as a CSV, so prod data, and then we could say file, we can store it into data, prod with preds, something catchy like that. We could fwrite because we've got dplyr, we've got data table as well, haven't we? So these prod with predicts, if I wanted to view that, it's outputted everything for me. And if I go to my file itself, there, it's in the data folder. Prod with predictions waiting for you. So it should be larger than the original file because we've bound those columns on. So that's essentially how you then consume that API. Another question I got asked at the start of the process is, so I've got my machine learning model, and what I want to do is I want to essentially create a task scheduler. I want to automate the training of that model, so it trains every week, depending on how much you want the model to pick up on the patterns. Normally with inpatient data it doesn't change much, so weekly is a good enough kind of strategy. If you had massive models with lots and lots of data, they can consume a lot of resource retraining. They can take days. So you'd want to really think about your strategy around retraining. So what I'm going to do now is I'm going to go to our original folder, so it's at the top left of the folder. I'm going to use a program called Task Scheduler to schedule this model that we've got. So I've got this ML training script that we developed in the first tutorial, and I'm going to, every time we get new data in, so new data's fed in to this, so at the start of the process in the input phase, real start of the pipeline stuff, so SQL in or CSV in or whatever, interfacing with another platform, I want to schedule it just to retrain on that new data. And it could even be these existing observations in our production data once they become stranded patients, and then you have a query that looks at the difference between those that are in the model and those that are in production. I'll leave that up to you to figure out. But yeah, then we want to schedule this machine learning model. So Task Scheduler is cool. It's got a nice user interface as well. So if you go to add-ins, I'm not going to use the user interface, but you can do this if you want. There's nothing stopping you. So add-ins at the top, you should find the Task Scheduler once the library's been loaded. Schedule our scripts on Windows. And you'll see that you've got this lovely little kind of shiny application that you can use. So I can select my model training scripts saying upload has been complete, and I can tweak with these different settings and it will change depending on what the radio button is that you've selected. Okay, I'm not going to do it through here though, I'm going to do it in command line because I just like to do it that way. So I'm going to load in our task scheduler, and a script to schedules that one, like I said, that we trained at the first start of the process. So again, pipeline step, this is the retraining phase. So I'm going to use Xdata, I'm going to use ML model training script in R, so it's got a link to your training script name. And the package is task scheduler, so this is a system file task that we're going to run. And then this is the real key part. There are examples of how to create cron jobs as well through this in Linux. But here we're going to do it on Windows because I use a Windows machine. So task scheduler's got a method called _create, and it wants you to give it a task name. So we're going to script this nightly or weekly. Let's call it weekly. That's a better description. And then the R script that it needs to trigger is this script to schedule. And I like it in code because you can schedule multiple parts of your pipeline. So if you did so for machine learning models, you normally split it into a couple of phases. I normally do my training step, but if I've got hyperparameter tuning to do, I'll also do that as a separate phase. I'd want to schedule that after the model's been essentially created potentially. And then I'd have an evaluation step, and then I'd have a putting it into production orchestration step like we just saw with the Docker container, and then you'd have your consuming steps, or how you consume it, which is what this webinar, this tutorial is all about. And then we're going to create this schedule. We're going to do it weekly. We're going to do it at 12:01, and we're going to do it on a Tuesday. And then let's create this. It's already created anyway, so it might get a warning here. Yeah, it's already created. And then you'd list your tasks that you've got running in R. And then if I looked at Windows Scheduler, you'd see at the bottom here, I'll have this stranded patient task, and it's started, and it's ready to go. So that's my weekly task that I've created, and this will then in Windows just kick off at that time when it runs, when it needs to run. So that's essentially how you then just quickly create a retraining task of your machine learning model using Task Scheduler in R. You could very easily create it in Windows Scheduler as well. Just do it as to run a little batch script that then triggers your R script, but that's a lot easier to understand how to do. So in this tutorial, we've kind of capped off parts of the process. We did how we'd access our API in Docker. We got our production data. We returned some. We sent that production data in JSON through to our API. The API sent the predictions back. We bound it onto our production data, and then we could put that into a database somewhere, or put it into a BI report, so business intelligence report, something like Power BI, to look at actually what our model's predicting. There's like a predictions tab. Finally, then in response to the second question around model retraining and how regular you should do it, again, the regularity is something that you need to decide, but you can use Task Scheduler to create Windows tasks. And there's also in Task Scheduler, there's a cron jobs one as well, which follows the same syntax as the Windows Scheduler. So I hope you found that really useful. Please let me know on Twitter at StatsGary if you've got any comments, feedbacks. Drop some comments into the YouTube channel, or just check out my tutorials at hudsonshacks.info. Alright guys, you stay well, and I'll see you next time.